Now we're going to learn how to name ionic compounds. So when you see the formula of an ionic compound, the question is, how do you name it? Well, it has two rules, very simple. The first rule is that the metal keeps its name. So you spell it exactly the way it's already spelled. The non-metal will change the ending to IDE. So sometimes it's a little tricky, but I am a little forgiving, so just try your best on how you think it would change the ending. So for example, Na on your periodic table, so look for Na, is sodium. So you're going to write sodium exactly the way it's spelled. Now, what is Cl? So look at your periodic table. Cl is chlorine. Now, we got to change chlorine to an IDE ending, so we're going to change it to chloride. Very good. So once again, Li is lithium, so we're going to write lithium. Br is bromine, but we need to change it to an IDE ending, so it's going to be bromide. Very good. All right, I want you to pause here, and I want you to try naming the next 6 on your own. And then once you press play again, then all the answers will appear, and then you can check to see how well you did. All right, so I would check all your answers. Barium fluoride, lithium nitride, calcium nitride, aluminum sulfide, potassium bromide, and barium sulfide. Another example I want to do, if you can squeeze it on there, is NaH. It's a pretty hard name. Na is sodium. If I can write sodium for us. Okay, hydrogen needs to end in an IDE, so it's pretty hard to imagine it, but we're going to write it's hydride like that. That means it's hydrogen. All right, very good. So now, on to the next page here. The same naming scheme can work with polyatomics too, but there are different rules. So you always need to count how many capital letters you have. Because if you have 2 elements, then you are going to do exactly what you did on the previous page. But if you have an ionic compound with 3 elements, that means that there is a polyatomic. Polyatomics are so special that they keep their name. You do not change their name. Okay, so that means the metal keeps the name and the polyatomic keeps their name. So I'm going to go ahead and tell you that all of these examples down below have a metal and a non-metal, so you know they're ionic. But now we need to count. So here we have 1, 2, 3 capital letters. That means that there is a polyatomic. The first one, or the first element here, is lithium. This polyatomic, you need to search for it in your list of polyatomics. Okay, so go look on the back and find MnO4. MnO4 is what we call permanganate. So I'm going to write permanganate here, because we do not change the name of polyatomics. You write it exactly the way it is. Okay, Casey didn't find it. Permanganate is right here. And then you're going to write the name exactly the way you see it right here. Okay, let's do a couple more examples. Here we have a metal and non-metal, but we have only 2 capital letters. That means we just have 2 elements. If we have only 2 elements, you're going to name the first one, name the metal, it's lithium, and Br is bromine, but we need to change it to an IDE ending. So this becomes bromide. Excellent. Okay, over here, we have K2CrO4. That is 3 elements, 3 capital letters. That means we have a polyatomic. K is potassium. So we now need to look for that CrO4. So over here, CrO4, can you find it? It's right here. So what is its name? Chromate. So you're going to spell it exactly the way you see it. So I'm going to go back and write chromate. Okay, so now I'm going to let you pause here and try to fill out the rest on your own, and then when you unpause it, you can check your answers. Alright, so I would spend some time checking your answers. First, I listed out how many capital letters each ionic compound had, so I could determine whether it had only 2 elements or if it had a polyatomic. Pause if you need to. Alright, so let's remind ourselves how to go backwards. So we've done this several times, but just to have a little refresher here. Okay, if you have the official name is lithium chloride, then we want to know how you would write that in a formula form. Now remember, there's no word Lewis dot here, so we're just talking about some scratch work over here. Also, a couple of reminders. Remember, if it ends in IDE, it tells you that it's a non-metal element, except, whoops, let me write this, fix this here, except hydroxide. Hydroxide is a polyatomic that ends in IDE, but it's a polyatomic. Okay, so if it doesn't end in IDE, it tells you it's a polyatomic, so you need to look at your list. All right, so here we go. Lithium chloride. Lithium is Li. It has a positive 1 charge. That I tells me that we're dealing with an element. So chloride is actually chlorine. Chlorine has a negative 1 charge. If we look here, then we do the math. +1 -1, how many of each do I need? I just need 1 of each. So I'm going to write lithium chloride. 1 lithium, 1 chlorine. All right, here's another example. Gallium oxide. So here, gallium is Ga. It has a positive 3 charge. This is ending in IDE, oxide. Okay, so we know it's probably the element oxygen. Oxygen has a negative 2 charge. So here you got to do the math, +3 and -2. Okay, how many of each do I need so that they cancel out? Okay, so if you do the math here, I'm going to need another gallium. So I'm going to have another +3 here. And I'm going to need 2 more oxygens. So 3 and 3 make 6, and then 2, 2, 2 makes 6 as well. So they cancel out to make a neutral compound. If I write that out, it's going to be, for every 2 galliums, I need 3 oxygens. All right, so next one. This is sodium nitrate. So we know sodium is an element, so sodium is a +1 charge. Now check out this ending, it's 8. So we are talking about the polyatomic nitrate. So you want to copy this down exactly the way it is, NO3 with that negative. So here I'm going to write NO3 and it has a -1 charge. You do the same math here, +1, -1, how many of each do you need? You only need 1 of each. So remember, you can write it 2 ways. You can write it like NaNO3, or you can take out the parentheses because you only have 1 of them. So it can either look like that or that. All right, next one. Here is iron with that Roman numeral 2. Remember what that means. Iron is Fe. That Roman numeral tells me it's positive, and that is the symbol for 2. Sulfide, that IDE ending tells me it's an element, which is sulfur. Sulfur has a -2 charge. So now we do the math. I have a +2 and a -2, so how many of each do I need? I just need one of each. So this becomes 1 iron, cancels out 1 sulfur. Perfect. Okay, last example is this nickel 3. Okay, so nickel's Ni. That Roman numeral tells me it's positive. That 3 tells me it goes there. Hydroxide, it has this IDE ending, but remember what I wrote right here. Hydroxide is the only polyatomic that ends in IDE. So if we find it, here's hydroxide, that IDE ending, okay? And then you are going to go over here, write hydroxide with a -1. Okay, so now you're going to do the math. You have a +3 and a -1, so that does not cancel out. So I need more negatives. So I need another hydroxide and another hydroxide for me to cancel out and make it neutral. So how do I properly write that? For every 1 nickel, I need 3 hydroxides. You have to have the parentheses here. Okay, let me just write it off to the side really quick. If you just write NiOH3, that means you only have 3 hydrogens, but that's not what you're trying to say. You want to say, I have 3 hydroxides, 3 of this OH, to cancel out my 1 nickel. Okay, so on the next page, I'm going to do just a little bit of scratch work to help you get started. And then you're going to check this practice page with the teacher. So here, instead of giving you a bunch of this empty space for scratch work, I'm going to try to teach you shorter ways to do this. Okay, so here, iron is Fe. This 3 tells me it's +3. The I tells me it's an element. Iodine is a -1 charge. Okay, so then here I am going to do my math here. +3 - 1. Hopefully you can do this math in your head, so then you can be like, okay, for every 1 iron, I need 3 iodines. Eventually, you can get really good at this, okay? So later on, you'll be like, okay, strontium is +2, oxide is an element, that's -2, 2 and 2, that's only 1 of each, so I just need to write SRO. Obviously, this takes time and practice, so you can write it however you want. So you can write it like this, or if you need a little bit more space, you're going to have to just get creative here. And hopefully you can go forwards and backwards with your ionic bonds.